Hello, here's Hendrik again, and today I'm going to show you a flow graph that was requested some time ago. It is based on the FGPS signaler plugin, and I wrote it from scratch to support some cases I thought were important to support. That means basically all Flownode data types. And what this node does is it can transmit values or the triggering of events between all flow graphs. So you can output in value in an entity graph, and you can reuse this value in an UI event flow graph or in any other flow graph or in a flow graph module or wherever you want. I will show it to you first how it works in the engine. Then we are going to debug a bit, and during debugging I will also explain to you how this new node functions, and then we're just going to release the node and set the version so you can see how you can redistribute your plugins too if you want. Okay, let's try this node out. First have to log in, of course. Yes. Okay, I will have my test map here. Starting with this tutorial, I will use the new FreeSDK version 3.4.5. I fixed some crash bugs, so it works a bit more stable now. So now we're just going to add a new Flownode. We are just going to assign a key to it, so we are using the game in the MISC start, and the input key, enable this, the key is K, and then we're going to use a new node, the ValueChannel string, and we're just going to name this channel test. So the value will be transmitted by this test channel, and the value we are going to use is hello world. So this is going into the channel when we press the key, and then it will be transmitted not only to this output but also to all other value channels with the inside the test. Oh man, I'm just going to move a bit away from the frogs so you can hear me better. And just we're going to just add a new additional node so you can see how it is to be used. We are going to display this message now here by adding now another value channel string and connecting this one to the trigger and the message, and we're using the test channel. So, and now if I press the key, K key, we're going to see this message. Let's go into game, and you can see the message is appearing. So we're just going to see how this works. Again, I enabled the debug mode and switch to game, press key, and you see the message comes through each time I press it. Okay, and the other side is, of course, let's go into game again. We input the value, yes, So, and we can also directly use the value here if you want to, but this doesn't have to be. And it works for various data types, for string, boolean, vector, entity IDs, and yeah, pretty much everything. So this is a nice way to reuse all this stuff. So, and you can just add another one if you like. Again, simply reuse this channel again, test, and output it again as hot message, trigger value, and this time to another position. So, and now you'll see two values coming out if I press the key. So this is pretty nice if you want to reuse some calculations or an event you set up in multiple parts of your flow graphs. So this was it for this demonstration of how it functions. Now we're just going to debug our node a little bit. I'll explain in parallel a bit how it works. I specified maximal recursion depth, but CryEngine handles this automatically, because what would happen if you connect an value channel to a value channel of the same channel, then it would transmit in circles, and this is called recursion. But CryEngine already handles it, and it will limit the recursions per frame automatically. And so I just added this as safety feature because it could crash otherwise. So another thing is, if you want to debug something, I already did this. You basically select here the debug version at the top, and Win32 or 64-bit version, and you go to the project properties, and you can set the editor or the launcher as project to debug. So we did this already, and we can now set breakpoints here. So we are going to explain some stuff and set some breakpoints to show it in action. So this here is an address information. Each flow node has the graph it is placed in. This is this one here. This is a flow graph. This is a flow graph. This is a flow graph. So this is saved as ID. Then there is a flow address. This is here, this node ID and the port number, and if it is an output or input port. So with this new defined structure here, we can address any port in the whole flow system. And here's our new flow node. I added a template parameter for all the different value types CryEngine supports, so integer, entity IDs, and whatnot. So they have a lot of data types, so I don't have to rewrite this thing. Then I defined a static map. The map is a list of stuff where we can instantly retrieve based on a string, and this string here is the channel name, all connected nodes, and all connected nodes are in this inside this list. And of course we store here a pointer of this class type with the correct value channel as pointer here. and this channel registry exists for each of these data types. So, and then we store the name of our current channel in our class, the address, and here we define our input and output port. So we have the channel name, the input value, and the output value. Then I defined here this additional private function, which is used to change the channel of a Flownode. If I add a breakpoint here now by pressing the F9 key and go back to game, and now I will change the channel name. Yes, and go into game. The breakpoint will trigger, and here you can see our new channel and the old one. And now the channel is changed, and yeah, this means if I press the key K now, nothing will trigger, because we just changed the channel of our input key. So for us to see the message again, we'll change this here, and now we'll see the message once again if I press the key, and it works again. So this is good to know, and we only want to look at the channel change if there is really a different channel. So we compare the current channel with the new channel name. Then we find the channel inside our channel map. This was the one above here. And first we're going to remove this node from the old channel list. We check is our channel existing. If yes, then we search this node by searching the address, the this pointer, so this node, and then we are going to remove it by removing this iterator. Yeah, and then our node isn't listening anymore on this old channel, and if our new channel name isn't empty, then we are going to add our node to the new channel name, and it automatically sets up a new list here if it isn't already existing, and then we are just setting that our current channel changed for this node. So this is all required to change the channel name, and we want our channel or address to be initialized to an invalid throw graph ID, because in the constructor of our node we don't know this yet. Here is some of the setup required by CryEngine, and if our node is deleted from the class, I'll set a breakpoint here now from the editor or game, then we want to set our channel to empty, and it will remove our node from the list. So I will demonstrate this now. I'll delete this here, and it triggers instantly the destructor, and our channel is removed from the listening list. So this is very handy to debug, because if you don't know what is happening inside your code, you can always step for step go through the steps. You can see all the settings here, break all, or step into a function call, step over a function call, and yeah, it's really handy to use. And you can also watch the values here. I will show you this later. So this is the configuration, also the standard stuff. And now we have here our process event function. This is the stuff where basically the events are coming in from for our node, and you can see here the graph ID and the node. You can watch the values here. The node ID is 2. It is the first port, and it's an output port. And yeah, we assign this here to store the current port of our current node so that we can transmit values to it later on. And if we place first the node, then we're just setting the channel to the first name, and that is the currently assigned channel name inside the editor. So this node is known to all the other nodes of the same type. And if a port is activated, then we first check if maybe the current channel changed, and if it did, then we call simply or change channel function here. And if the input value changes, then we need to transmit our new value, and we get here invariant port information. So we get inside here integers, booleans. It can store any data type. And then we're going to search our new channel we are currently on, and if it exists, then we are going to send to all nodes belonging to this channel and data type this new value. And we're going to do this by retrieving the graph ID from the address for all the nodes inside this channel. So we retrieve the graph ID because each node could be in a different graph, and if the graph still exists, so we get a valid graph ID, then we are going to activate the output port of another node. So we are not currently inside our own node, but inside all the other ports. So we are activating here an output port of another node. So what this means is I have to continue first. Okay, what this means is the following. We get our input value, it activates, and this node here, it will activate this port, and the value will come out here. So this is very important. So we use the address of this port, and then we transmit the value. Okay, so that was it for how this node functions, and you already saw how to watch values in the debugger and how to debug your Flownode. So we're just going to look at how I implemented the types, and I see I missed one data type. So we're going to add this now, and the data type I missed is the Untitled ID data type. Yeah, basically integer Untitled ID data type is the same, but yeah, we'll add it anyways. So we'll build it again, and now we'll always have an Untitled ID data type. So what this create value channel type function does, it creates an instance of the channel map. So this is the static variable which we declared inside the class here. Static variables need to be defined outside of the class. So this is what we're doing here. We define it with the correct data type, and yeah, and then we registering on your Flownode. We do this by using this part of the string and the t name. This is the human readable name, and we concatenate this with the preprocessor, and again we input here on your class, and here we concatenate again just simply for the register Flownode X to the correctly the value type and class name. So we support integer, float, numbers, a string, simply triggers or event, vectory, and booleans and entity ID. Just checking if the entity ID shows now up. I used for this node the Doxygen syntax to document the functions. You can look up Doxygen. It's a nice way to document your functions, and you can generate HTML help out of it, and it's also used in the CryEngine SDK itself. So it's recommended to use this Doxygen syntax to document what your functions or what your variables mean, whatever. So now it's just checking if it appears, and now here we have the entity ID, and here it's also the current. Okay, works perfectly. We're going to close this up now, no changes. Okay, and now we're looking how to upload this to the internet. I already wrote here in the README what it does, and I'm going to add the changelog now here. And then we're going over how to upload this. Okay, build it, works. So we are closing now the editor and going to the directories where we can use our build tools. And in the tools folders you have the script build, and we are not going to use it just now. We are going to first set the version for the various stuff plugin to the one we are going to use now. And inside the plugin SDK folder under tools, set versions all, not here but here, we have this file where we can change the version of our plugin, and we are just going to call now set versions all, and the version changed now of our plugin. If you look here, it automatically changed the numbers here, so we don't need to go into all of those files manually. So it also changed the stuff in the installer. So we are going to build now our redistributables and the installer itself, and we do this by going back into the folder and calling build. It now builds the various stuff plugin in 32 and 64-bit version, and it places those files inside the bin 32 and 64 folders, and the ANSYS install generator will find those files then and build an installer out of it. So now we're going to build the installer. You can see now here we have our new version. We have the correct version information here, and we also have the correct version information here. So this is pretty nice to have. so people always know what version they are currently using. So we are going back into the plugin SDK folder, and there I have another utility. It is called upload all, and I will call this now, and it will now upload my plugin to the bin tray. The other plugins aren't currently built, so it only uploads a new one, and I can see this now here. And I'll look at what changed. It was this one, okay, and it all created a new version for us automatically, and we're just going to publish this now. So now the file is available for download, and for the web installer to download this file instead of the 1.03 release, the web installer looks into this file and now sees if I commit this the new version. So we're going to commit on a version now. Okay. We are going to synchronize this, and then we are going to add the version tag. And I prepared this here already. We are going back one area again and clicking here, open a shell here, and then we are going to say git tag a so this will create the new version tag locally, and then we're going to push this to github.com. So now the new version is publicly available, and you can download the source code now here, and yeah, you can see the changes we made here for the new node to work. And yeah, you can use the plugin SDK web installer if you want to use the new plugin directly. So this was it for this tutorial. I think in the next tutorial I will try to cover how to customize your installer, your plugin installer. So the next tutorial will be about basically here, this file, this ANSYS file. I don't know if you people already know ANSYS, or yeah, we'll have a look at how this ANSYS works, which generates or installer exe. So thank you guys for listening, and see you again maybe in 2 weeks or something like this. Okay, thanks and bye.